You've probably used tools like ChatGPT, right? But have you ever stopped to wonder how they actually write? Well, we're about to pop the hood and really demystify this whole thing, breaking down exactly how an AI can generate such incredibly human-like text from just a simple prompt. I mean, really think about it for a second. You type in a question, and just moments later, a full, coherent, often creative answer just appears. It honestly feels like magic. But it's not. It's a really precise and fascinating process. And today, we're going to see exactly how that engine works. So yeah, in this explainer, we are lifting the hood on what we call large language models, or LLMs for short. We're going to break their entire operation down into just 3 fundamental concepts. Seriously, that's it. By the end of this, you'll have the complete blueprint for how an AI writes. Okay, so let's start with the most basic piece of the puzzle, the absolute engine of text generation itself. It's a concept called autoregression. Now here is the most important thing to get your head around. An LLM does not plan out a whole sentence or paragraph in advance. It's basically a prediction machine, and it's obsessed with one simple task: guessing the very next token. A token is usually a word, sometimes just part of a word, and it just keeps guessing the next one over and over and over. It all works in this really simple but incredibly powerful loop. First, the model looks at everything so far. That's your prompt and everything it's already written. Then, based on all that, it predicts the single most likely next token. It tacks that new token onto the end of the sequence, and then the whole process just starts over. That's the loop. And as the formal definition right there, autoregression is just the fancy way of saying next word prediction based on all the previous words. Pretty simple, right? But, this leads to a really, really important question. Okay, so if the model is looking back at, say, thousands of previous words, how on earth does it figure out which ones are actually important? How does it remember the main topic from the first paragraph when it's all the way down writing the 10th? This was a massive problem for older AIs. They just lose the plot. And that brings us to our second key idea. The answer is a truly revolutionary concept called attention. This was the brilliant breakthrough that finally solved that long-term memory problem. You can think of it as the model's ability to focus on what matters, and just as importantly, ignore all the noise. Think about it like this. When you're reading a textbook, you might use a highlighter on the most important phrases, right? Well, the attention mechanism does something similar. It gives an importance score to every single previous word. The words that are most relevant to what it's trying to say right now get a massive score and have a huge influence on the next word it writes. So how does it actually calculate those scores? Well, it uses this really elegant system with 3 parts for every single token. The easiest way to think about it is like a researcher in a library. The query is the question the researcher has in their head right now. The key is like the title on a book's spine, advertising what it's about. And the value is the actual information, the good stuff, inside the book. So what the AI does is it takes its current query, its question, and it checks it against the key of every single previous token. When it finds a strong match, like finding the perfect book title, it then pulls the value, the information inside that book, to help it make a way, way smarter prediction for the next word. I can't overstate this. This mechanism was a total game changer. All of a sudden, models could handle incredibly long, complex texts without forgetting what they were talking about. It also made training them way more efficient. And most importantly, it gave the AI a method to laser focus on what truly matters in a giant sea of words. Okay, so we've got a process for generating words one by one. That's autoregression. And we've got a mechanism for focusing on what's important. That's attention. But what holds this all together? What's the container? That's our third and final piece, the transformer. The transformer is the architectural blueprint for every single modern LLM. It's a structure that was specifically designed from the ground up to take full advantage of the power of that attention mechanism. It lets you stack layers and layers of processing to understand and generate language at a truly massive scale. Now, if you were to crack open a transformer, you'd see it's made of these repeating layers, kind of like what you see here. And each layer does 2 main things. First, the self-attention part figures out how all the words in the sentence relate to each other. Then all that juicy context gets passed to a network that, to keep it simple, we'll just say thinks about it more deeply. You just stack these layers, and the model builds an incredibly rich and nuanced understanding of the text. And you should know, not all transformers are built the same. Some, like BERT, are what we call encoder only. They're just built to understand text. Others are for tasks like translation. But the ones we're talking about, the GPTs of the world, are decoder-only models, and they're architected specifically for that first principle we talked about, generating text, one word at a time. So let's put it all together now. This is the moment. This is where those 3 core ideas we've been talking about are going to click into place and you'll see the whole picture. First up, autoregression. This is the fundamental action. It's how the model writes, by predicting one single word after another in a continuous, relentless loop. Second, attention. This is the intelligence that guides the whole process. It's how the model makes sense of complex relationships in the text and decides which of the thousands of previous words are absolutely critical for making its very next choice. And finally, the transformer. This is the architecture, the brilliant blueprint that actually houses the attention mechanism and allows this entire process to run efficiently and at a mind-boggling scale. And that brings us to the secret recipe. When you put all those pieces together, here's what you get. A modern large language model is simply a large decoder-only transformer that is powered by self-attention, executing one core task, autoregressive next token prediction. That's the whole game. So here's your final cheat sheet, the takeaway. Autoregressive is the action. Attention is the focus. Transformer is the structure. And an LLM is the final product that brings it all together to do its magic. So we've gone under the hood. We've seen the engine. These 3 principles are what's reshaping our world right now. And that leaves us with one last big question. Now that we all have the blueprint, what are we going to build with it? Thanks for joining this explainer.